So the next paper that I'm presenting today is Mobile Augmented Reality System for Object Detection, Alert, and Safety. So I was talking about VR up till now. Now we're talking about augmented reality. So let me start with the background of the work. So situational awareness is critical component to evacuation process for both fire responders and the building occupants, which are the evacuees. Right. So both parties must be aware of 3D spaces and multi-level building. So when there is an emergency, sometimes it's not, even when, let's say, fire responders, they come to a building, they might not know the layout of the building or where things are, where people are. So there's a need to present that information straight away to the user. And paper-based maps have been there, but now with smartphones and with technology, you could actually talk about creating a dynamic view of how things have broken down because of the emergency situation, and creating something and like an updated information of what the layout is, and give that specific information to the users as well as to the fire responder or other emergency personnel. Right? So there's a need to create these 3D visualizations of these spaces and convey it to the users in a meaningful way. So buildings might have many floors, and individuals might get easily confused sometimes which floor they are in, because most of the times they kind of look symmetrical, and sometimes people do get lost. We are on the second floor, third floor, or the fourth floor. Right? So these are kind of default things that could be very easily done through the use of augmented reality. Right? So this is a screenshot, simple screenshot of looking at a marker. In case this in this situation, this marker is like a room number. If you go to a building, any permanent signs in the building, they act as markers. So we basically using feature extraction. So the more markers you have in the building, the more you can locate a person. So our idea is that in emergencies, GPS fails, wireless systems also fail. Right? So this is a different way of doing localization, of finding where you are. So if you are detecting this marker, that means you are present in front of that building. So if that room number is there, there's nowhere else that room number would be there, right? So the idea is the more images or more markers you capture in a building, the better the system would become, right? So the database, if it has more permanent features, the more better it will automatically become. So our goal was to use these markers and then let the user know where the exits are, and depending on the emergency, tell them which is the shortest exit to use. Right? So again, there could be multiple exits and there could be multiple paths. So depending upon where the emergency is and where the user is, you can give a user-specific direction or the path towards the exit. So we have created these ARI modules, we call them augmented reality instructional modules, to help user evacuate the building in case of emergency. And of course, it could be used for navigation, for alert, and for safety information also. So the idea is, again, to create these modules for 3D visualizations, and they're better than, you could actually use a 2D marker. So most of the buildings have 3D floor plan or 2D floor plans on the building. You can use those 2D floor plans to project out the 3D floor plan in the first place, right? So that's kind of default also, because again, those are also permanent features in the building. They will also act as markers. So our idea is that injuries and casualties can be avoided through the established communication of evacuation plans to the users. And augmented reality has shown to be an effective training and teaching tool, since it captivates the learner's attention through a combination of learner's physical surroundings as well as computer-generated elements. So our mobile augmented reality application was developed in Unity 3D with Euphoria asset, and we also combine it with navigational features. So in a campus, we are always looking for things around in a campus, in a university campus I'm talking about. So you have a lot of buildings, you have parking lots, you have a lot of food places, you have fuel stations. So we used all those situations to create this module to find the closest buildings or closest eating places, which are kind of default in that application. And we have used Google Map API to incorporate those situations. This is a system architecture for the mobile augmented reality application. Again, the implementation was done in 3 phases. You had a graphical user interface for the mobile application, then we integrated the augmented reality component, and then we integrated GPS onto it. So this is kind of a main screen for that application. The top 2 buttons basically are pointing towards the augmented reality emergency evacuation, which is it will basically open up the camera, and then you can use it to move around on campus, and it will show you the evacuation plan in 3D. And it will show you where you are, and it will have different layers where you can select different options, which would be more easily viewable in the demo, which would be later on coming. The second one is augmented reality department finder. So again, depending upon which floor you are in, it will give you directions of you are on the 2nd floor and you might have to go to the 3rd floor in order to go towards the department. And then you have a list for all the buildings on campus, and it will connect you through the Google API, and it will give you directions from your current location to the building, which is kind of default, which kind of is similar for the other options also, parking, food and drinks, and gas stations. So again, we incorporated all the permanent features, room numbers, ATM machines, and any permanent sign that is there inside the building basically acts as a marker. Anything that is non-permanent, like flyers, they will not act as a permanent marker. They might work for a small duration of time, but they might not be there later on. So again, all those floor plans and those assets were brought into Unity, and then we used the Euphoria asset to work on it. So floor plans, again, they were presented. They show the current location. So out here, the red pin shows where the user is. And of course, you can zoom in and zoom out using your fingers inside the tablet or the phone. And you can find the closest, nearest exit, shelter locations, refugee areas, or AED, or where automated external defibrillator is there. So this one is showing the department finder. The image shows that the department is on the 2nd floor, so you have to take a staircase on your right in order to go towards there. And then it highlights where you are. The second image is showing the pin where you are as well. This is looking into the GPS aspect and finding out the buildings, the parking structures, the food and drink places around, and as well as gas stations. So let me see if I could play this module. So this is a module using the tablet right now. So you have, so you have the person who's using the tablet, then he's walking towards in the lobby, going towards another marker, and then can of course zoom in and zoom out. And then you can obviously go towards another marker. So in the interest of time, I'll go towards the second demo, which is using HoloLens. So again, the good point is that once you develop the environment in Unity, you could easily take it to different platforms. You can take it to mobile platform as well as HoloLens. So again, this is using HoloLens. So out here, there are buttons. You can add more layers of information on top of it. You can add room number information or the exit where those are. Of course, you don't want to present too much of information at the same time to the user. Otherwise, it overwhelms the user. So you can select based on your needs. So let me go back. and put that on top. So we did a limited user study once again. We used the mobile phone usability questionnaire framework, and we had same 10 participants for the application, and we collected data which was based on 5 Likert scale, and the questions were related to the engagement, their familiarity, and the functionality of the application. So out here, 92% of the users had an above average and extensive level of experience using mobile applications, and mostly all the users agreed that this mobile augmented reality application was useful in identifying the nearest exits, and they felt that this application is a good way to navigate and could be used as an educational purpose as well. So this paper presented an integrated situational awareness mobile augmented reality application for smart campus planning, management, and emergency response. The idea was to build a situational assessment module for emergency response, as well as for occupants, as well as for security personnel or fire respondents who are coming inside a building which they don't know. Right? So this was developed in Unity 3D for tablets, for smartphones, for HoloLens, and it's based on a quick, robust marker detection technique, which is inspired by the Euphoria library. And it incorporated the existing permanent features, which act as location sensing option also. And we use them as triggers to trigger the 3D floor plan on top of it. So in our future work, we would like to conduct more user study, as well as look into comparing our data with a 2D paper evacuation plan also, and develop dynamic routes to exit depending upon the situation in augmented reality dynamically. And of course, look into taking it to the iOS system. Because it's developed in Unity, you can easily do that. But again, bringing that and doing testing for that is the next thing to do. And following the last thing is looking into creating a generalized neural network algorithm for a new building. So if you go to a new building, you can take up your phone or the HoloLens, go to a particular spot, take a picture, so that location and picture is captured over there. The more, it's like it will act as like a training phase for the system to create a marker, to take a picture, and that will act as marker, that will act as location. As long as you have the inbuilt floor plan inside there, then you have basically created it, customize it to a new building, and then you can start using it. So you can generalize that module so that it can work for any building. These are a couple of references and a couple of acknowledgements for a couple of awards. And thank you very much. And any questions?
Excellent. Thank you.